Okay, so welcome back. Happy Monday. Our quick look at the calendar tells us that today we are graphing parabolas. We will use some of the things we learned last class where we were solving quadratic equations by factoring. We're going to use some of those techniques in order to help us graph parabolas. Coming up the rest of this week, we have Wednesday, quadratic formula day number 1, Friday, quadratic formula day number 2. Then the following Monday, 1 week from today, quadratic models, which translates to word problems, where quadratic equations are the tool that we'll use. And then finally, a week from this coming Wednesday is quest number 4. So that's coming up. This won't affect us, but tomorrow is Veterans Day and there are no day classes tomorrow. So if you have Tuesday day classes, they are canceled tomorrow. Questions on the calendar? Okay, so then let's take a look at the top of page 44. It says, in today's class, we'll learn how to graph quadratic equations. And then there's this example down here where we're going to plot a bunch of points and graph a few parabolas on the axes. I decided I'm not thrilled with that example, so we're moving on to page 45. And we'll take a look at these 3 parabolas that are graphed. It says up here the 3 equations. One of them is y equals 4x squared minus 4. Another one has that equation, and one of them has this equation. So the first thing I want to do is figure out which one of these is which equation goes with which graph. And the way we're going to do that is by plugging in x equals 0. So if you plug 0 in for the x, then this term right here just disappears, right? Because it's 0. So how much is y? Just -4 by reading that equation. So that means that 0 and -4 is on that graph. Agree? Is that the X-intercept or the Y-intercept? That's the Y-intercept. Okay, and then we'll do the same thing on the middle equation. We're going to plug 0 in for both x's. So anything with an x in it disappears, right? So both of these terms vanish out to 0. And so how much is y? 60. And so you can see why I'm picking 0 is because it's really easy to plug 0 in, right? But if I said plug x equals 17 in, well, that would be some calculations we'd have to do. And then we'll do the same thing on this last one. What do we get here when we plug 0 in? -25. Okay, so given those 3 points, can you look at the graphs and figure out which one is which equation goes with which graph? So take a moment. Label the 3 graphs with either y sub 1 or y sub 2 or y sub 3 based on what we just figured out up here. And then check with your neighbor. Okay, the graph that's blue on my paper, which one is that? That's y sub 1. Because we can see down here the point 0, roughly -4. It's hard to tell exactly. Okay, the green one here, how much, which one is that? That's y2, so we'll label this one green. And that was because this point up here is at 0, 60. And so process of elimination tells me that the red guy must be y3. But does it jive? What was the y-intercept on this one? -25, and that seems reasonable looking at the graph. Okay, so we figured out which one is which, and now we're just going to talk a little bit more about these curvy things. We skipped over this on the previous page, but the graph of each of these equations is called a parabola. Might have heard that word before. And there are some telltale features of parabolas. For example, every parabola has either a bottom point, like a lowest point, or a top point, a highest point, right? And there's only one of those on each parabola. And that lowest or highest point, it has a name. Anybody know the vocabulary word for the lowest or highest point? Apex is a good word. That means highest point, right? Vertex is a math word that means the highest or lowest point. So the vertex of a parabola is its highest or lowest point. So that's the definition of the word vertex, the highest or lowest point. The parabola is facing the other direction. You mean like, yeah, good question. So all the parabolas that we study this semester are either going to be opening upwards like blue and green or downwards like red, but there's no harm in drawing a sideways parabola. The vertex of this parabola is its most extreme point. It's the one that has this kind of unique characteristic where things really change. So the vertex would be the rightmost point on this one, or if we flipped it around, the leftmost point. You could even have parabolas that don't open in any of the nice cardinal, the 4 directions, and we can still identify the vertex. It's hard to describe, but I know it when I see it. Good question. Okay. So let's talk about this opening up or down business. So again, blue and green open up and red opens down. And there's something in the equations that tells you right away whether the parabola is going to open up or down. Anybody seen this fact before? Kira? Yeah, which negative are you talking about? So what negative tells you it opens up or down? The Y-intercept. No, it's not exactly about the Y-intercept. Yeah, it's the kind of leading term, what we call it. So looking at this beginning term in each of them, 2 of them have a positive number in front of the x squared, right? Positive 4 and positive 1. But the last guy has a negative 1 in front of the x squared, yeah? And that negative is the one that opens downwards. And we saw that. We saw that y3 was the red one. And the other 2 open upwards. So here is a fact. So first I'll just write our formula in general. But I think we saw this formula last class. Y equals ax squared plus bx plus c is our most generic looking quadratic equation. A, B, and C, even though they are letters, they're numbers. They're supposed to represent constants as opposed to x, which is a variable, and y, which is a variable. So here's the fact that we're kind of leaning towards. If the A is positive, then the parabola opens which way? Opens up. And if A is negative, then it opens down. And not really much one for memorizing this kind of a thing, but if you are, here's a little mnemonic device you can use. If you are generally a positive person, how can somebody look at your face and know that? Because you're smiling. And if you are generally a negative person, then perhaps you are wearing a frown. So the positivity or negativity of A kind of determines how happy or sad the parabola is. I know. All right. So that's good. And let's say one other thing about the vertex. Let's talk about intercepts, X intercepts first, actually. So how many X intercepts does the blue graph have? 2. 2 places where the blue graph hits the x-axis. How about the red graph? Just the 1. And the green? None. And so those are all the possibilities, actually, for how many x-intercepts a parabola could have. So we'll write that over here. Every parabola has 0, 1, or 2 x-intercepts. And do we buy that it could never have 3 or 4? Like if this is what parabolas look like, could you make a parabola that hits this, this, and this? Yeah, I mean, in order to do that, we can start drawing a parabola, but then recognize, well, shoot, we missed the last one. And so if you have this urgent need to hit it, then you better change behavior. And there are functions, there are graphs that look like that. But a parabola is not one of them. A parabola doesn't have 2 different turning points. It has only 1. So, so these are all the possibilities for how many x-intercepts. And the other thing about this, if I look at that x-intercept and that x-intercept, just naming the x coordinates, what are they? -1 and 1. And would you guys buy that the vertex of that parabola is perfectly halfway between those two x-intercepts? Right? The vertex, that bottom point, is exactly halfway between. And it's true for any parabola that you draw that has two x-intercepts. So I'll just draw something like that. And if I look at this x-intercept and this x-intercept, and I take that guy and I go halfway in between, if I've done this right, then the vertex should be exactly in the middle, right? So that's going to be an important fact for us. The vertex is halfway in between the x-intercepts. Okay, so what we're going to do, the heart of today's class is about sketching parabolas, and it's a long process that's listed all here. We're not going to read this right now, but you'll have it for reference when you start the activity and work on your homework. So let's just try this one together. The goal is to sketch y equals -x² plus 4x minus 3. Okay, so in order to graph a parabola, we've got a bunch of things that we're going to do. I'll try to do them in the same order as on the previous page. So the first one is to figure out the value of a. Remember, it's supposed to look like ax² plus bx plus c. How much is a in this case? A is -1. So which way does this parabola open? Down. This is an unhappy parabola, so it opens down. Okay, so that's the first part. Next thing we'll do is find the y-intercept. How do we find the y-intercept of anything? X equals 0, right? It's always the other letter equals 0. So we let x equal 0. And so when we plug 0 in for x here and x here, y is -3. And we find the y-intercept not because it's like such a special point, but just because it's so darn easy to find, right? We're just getting really cheap information that's useful to us. Okay, so that's the y-intercept. Let's take a look at the next thing, x-intercepts. Okay, how do we find x-intercepts? Well, that y equals 0, just the other variable equals 0. And so then I'm going to copy my original equation, but instead of the y, we're going to put 0. Okay, and how do we solve an equation like that? Yep. How do we solve, yeah, maybe factor. I mean, the equations that we solved very last class look like this, right? So first step was to get one side equal to 0. This is from last class. All right, we've already got it. Second step is to try to factor. All right, so what's kind of awkward or maybe a little bit different for this guy compared to most of the other ones we factor? It's got that negative in front of the x². So you have choices here. You could take everything on the right-hand side and just flop it over to the left-hand side, which would make that x² positive, yeah? In fact, that's probably what I would do. But instead, I want to do something different here because there was an example we did on the box day where we would factor using the box. And I need to update something that I had said. I gave you guys like this little shortcut that turns out to be true as long as the thing you put in the top left box is positive, but isn't true if it's negative. And when I said it, I thought I was saying true things, but it turns out I wasn't. So let's fix it. We're going to do the box method on this one. Again, personally, I would move everything to the left-hand side and then just factor it normal. This is a pretty easy product sum example, but I need to fix this thing with the box. So what goes in the top left? -x². Bottom right? -3. And then what do we do with those two things? We multiply them. So we go negative x squared times negative 3, or just positive 3x squared, right? Okay, and so then what we're looking to do is find two things that also multiply to 3x squared and add up to 4x. Yeah. So the choices for 3x squared are either 3x and 1x, or negative 3x and negative 1x. Those are the only things that multiply to positive 3x squared. And again, we wanted the one that adds up to 4x, so it seems like the positive is the one for us. So let's take those guys and put them into our box. It makes no difference what order you put them in, but put them in that order just so we're all looking at the same picture. Okay, now we're going to factor out whatever we can from everything. So let's see what happens here. So forgetting about the signs, what can I take out of the top row? This top row right here, we see there's an x in both. So let's pull out x. Bottom row is a 1. First column, also x. Second column, 3. Yeah, we'll deal with the negatives in a second. So we just took only positives, and then we're going to deal with those negative signs. So the shortcut that I handed you guys a few classes back said you just take a look at the leading entry in the row or column and you copy that sign. And so like over here, that's a positive, so this would stay positive, right? And here that 3x is a positive, so that would stay positive. And then up here, what would we put? Negative. And then out here, what would we put? Negative. And the problem is that when you multiply this thing and this thing, what do you get? Positive x squared, but what do we need? Negative x squared. So I lied to you guys, and I just feel so badly about this. Like I've barely slept since then. Actually, I've slept fine. Okay, so here's what we're going to do instead. We're going to forget the shortcut. We're just going to look at this negative x squared, and we're going to say, okay, how do we build negative x squared with a positive x and a negative x? And to be honest, it makes no difference which one you pick to be the negative. So you just pick one. Doesn't matter. But they can't both be negative, is the idea. Okay, and then we just play this little detective game. It's not a very hard game, but let's play this detective game. We know that we're supposed to take this guy and multiply by this guy and get what's in the box, right? Does it work at the moment? If I multiply those two things, do I get what's in the box? No, I get negative 3x. Well, the only way to fix that is to do what? Is to make that 3 up there negative. Right? Like you have to get the products that are in the box. So the sign choices that we make need to, they're dictated by what's in the boxes. Okay, and then we're going to look at the bottom row. So I'm going to draw some stuff and then I'm going to erase it because the diagram's getting kind of cluttered. So we decided that was negative. And now if I multiply that x by this 1, do I get what I wanted to get? Yes, I do. So I'm happy with that. When I multiply this negative 3 times this 1, that works too. And so this is our answer. Like all the products work. Jasper. Mm-hmm. You'll get a different looking answer that will be equivalent to what we have, which is totally okay. All right, so what that means is that this equation becomes 0 equals. So we just write down what's the thing on the top say. It says x minus 3. And on the side, what does it say? Negative x plus 1. And if you lobster claw that or foil it, you will see that we get exactly what we had at the start. Top one can't be x. You're talking about this one? Why can't it be negative? So we're making that a negative. And then to get this guy down here, I can see that this one over here has to be a -1. We would have had to make that one positive. And this is a slightly different looking, but perfectly correct. It's perfectly correct what we have up here, even though it looks a little bit different than what we have down here. So what I can say definitively is that you just make either choice and you will get an answer that's right. Whether or not it looks exactly like this, maybe not, but that's okay. All right, so I think we're good here. Yeah, okay, so then, so I've got that, and then we go to the next step because we factored, and now that it's factored, what do I do with each of these pieces? What do we do with each of these pieces now? Set them individually equal to 0. So either x minus 3 is 0, or negative x plus 1 is 0, right? The factoring part of this problem is the toughest part of the graphing the parabola. And so here we get, by adding 3 to both sides, we get x equals 3. And over there, x equals 1. Might take a couple of steps on that one. Okay. And so let's go ahead and start plotting some of these points. We've worked hard to get some points, so let's plot them. So we'll start with the y-intercept. X was 0, y was -3. That's right there. And then we just found these two x-intercepts. One of them was at 3 and one was at one was at 3, one was at 1. One of them is at 3, one of them is at 1. Okay, so those are our intercepts. That -3 was the y-intercept. It's not going to work? Which way does this parabola open? Down. Is it going to work now? Yeah. Like if you're hoping for an up opening parabola, then your eyes were telling you there was a problem here, right? We knew from the beginning this was a downward parabola, and I can draw a parabola that hits those points, that opens downward. Let's just do a tiny bit more work, and then we'll draw our parabola. Okay, so we found the y-intercept, we found the x-intercepts, that's the hardest part. Next thing we're going to do, I think it's part D that we're up to, is to find the vertex. And if the x-intercepts are at 1 and 3, then where's the vertex? Is it 2, right? It's halfway in between. So find the vertex by averaging the x-intercepts. Okay, so we average 1 and 3. We get 2. And I'm writing up the average formula just in case the numbers were not as easy as this. You guys know how to average two numbers. You add them and divide by 2. Okay, that's the x-coordinate, but we also want the y-coordinate because I'm about to plot a point where the vertex is. If you know x is 2 in this case, how do you find the corresponding y? You plug 2 in. That's what the equation of the parabola tells you. But if you know the x, you can plug in and find the y. So we're just going to plug x equals 2 into that equation up there, and that will give us the y. So y equals, so we're just copying that negative, something squared plus 4 times something minus 3. And what's the something that goes in the parentheses? It's the 2, right? So I'm going to bring this back up now. What happened? This one here. So it's the original equation, this guy right here, but I just changed those x's to parentheses because I knew I was going to put a number in, and the number I put in was x equals 2. That's what Julia said we should do, right? If we know x is 2, and we want to find the y, we can plug any x we want in. Okay, so let's do this calculation, and then we'll have our points. So what do we get here? Is this positive 4 or negative 4 then? Negative 2 squared. Yeah, that negative is sitting out there. And remember, exponents are weak, and they don't have as much reach as some folks think. So that's a negative 4 plus 8 minus 3, which is equal to 1. So that means that the vertex has what coordinates? 2, 1. So go ahead and plot the vertex at 2, 1. 2, 1 is here. That seems reasonable. Okay, and there's one last point we're going to plot before we connect the dots. And the last point that we're going to plot, I mean, you can imagine, you can see this parabola pretty well, right? Right, it looks something like that. We're just going to plot one more point. You guys are smelling each other back there. You okay? Yeah? Yes, Sam. Yeah. So Sam has one more point that he thinks we should plot. Shh. So here's the last point we're going to plot. We're going to imagine that parabola. And we're going to draw a vertical line that goes right down the center of the parabola. It's called the Axis of Symmetry because the parabola is symmetric around that line. Imagine that. And all we're going to do is find the point that corresponds to the Y-intercept. There's a point on the other side of the parabola, on the other side of that green line. It's the same amount over, right? It's just the symmetric point. There's just one more point over there to help us. That's all. So, there aren't any formulas we're going to use. We're just going to think this one through. So how far did we have to go to get to we had to go 2 over, so then we better go another 2 over to find this symmetric point. Do we buy that? Right, that's the symmetric point. So the symmetric point is 4, -3. So I think that's what we're going to call E, is the symmetric point of the Y-intercept. Is 4, -3. Okay, now once you got the dots, connect them all, we're good to go. Any questions on the process? It's a rough sketch. Rough sketch, Ashlyn. It should continue definitely past those 2 points. Like, I have a lot of latitude in terms of grading people. So it doesn't have to be perfect, but there are certain things that I see every semester that I take points off. So let me be clear what I don't want to see. What I don't want to see is that, because parabolas are curvy. And the other thing that I don't want to see is this, which is a beautiful looking part of a parabola, but the parabola doesn't just cease to exist at the last 2 points that we plotted, right? So make sure it continues all the way to the bottom of the grid. Kira. That's the idea. Yep. And all the steps are, again, written on the previous page. So we just kind of talked them through, but they're written out in all their detail on the previous page. So go through the activity. I'll come around and help. I'll check homework as well and see how far you can get.